Welcome. This week, week 9, in Data Governance, Ethics and Law, we'll talk about encryption, blockchain, and other emerging technologies and how they relate to data governance. As part of that work, we will describe the essential role of encryption in managing consumer and company data. We'll compare and contrast blockchain to traditional storage systems for data privacy and security solutions. We'll analyze the environmental impact of blockchain and cryptocurrencies along with the viability of possible solutions, and we'll advise how to analyze a real-world example of a company updating its encryption policies for the future. And in terms of to do and deliverable activities, you'll read and watch videos as usual and participate in discussion board and also in quiz. The case study assignment is assignment 2 is due, and then module 10 assignment we'll just discuss this week, just to give you an idea of what to do next week. So week 9 case studies are the following. There are only 2 case studies you are reading you are going to do. Select from among the case studies in each module for your data governance case studies assignment due week 9. In addition, your instructor will tell you which you are required to read this week. Some case studies provide international and diverse perspective and all give context to be more general readings on a topic. So here are 2 case studies. Basically, it describes the faculties about the duties. So you have 2 case studies here. Don't assume China will ease crypto restrictions anytime soon, published in Forbes. The other one is published in as-coa.org. So that article it's an explainer about crypto in Latin America. So those are two case studies. And in terms of the discussion board participation, blockchain and cryptocurrency are growing in importance and increasingly integrated into various sectors of business, government, and the economy. In readings, video, and a case study, this week we explore blockchain and/or cryptocurrency from several perspectives: impact on the financial sector, effects on the environmental ecology and climate change, because it uses enormous amount of energy, and a possible key to the future that can help poorer economies gain a foothold on the world stage. After reviewing the materials, please answer the following questions. Okay? Considering these factors and any others not mentioned, what in your opinion is the most pressing issue concerning blockchain and cryptocurrency technologies today? Explain your choice. And then, do you think the issues you discuss can be mitigated in the future? If so, how? If not, why not? The third one is, do you think environmental and energy costs will eventually doom Bitcoin and other cryptocurrencies to failure? Explain. At least one response to others post, up to 3 points. Okay, is valid, useful, valuable. Regarding the creating a data governance framework project, your team will prepare and record your final data governance framework presentation for a hypothetical company. Assume that this is a competitive bidding situation and that your client, stakeholders, and board are the audience. The deliverable for this assignment is a 15-minute recorded presentation. Your goal is to convince the client to award the work to your strategy consulting firm. Consider the following as you create your presentation. You may use the same hypothetical situation, hypothetical organization you selected for your digital trust submission, that is company XYZ, or choose any other name. Like the previous recorded assignment, your hypothetical organization can be modeled after a real organization or one that you invent. Again, you will need to align your presentation with the company's industry. Okay. If you are talking about your company is addressing for healthcare, make sure you align your presentation accordingly. Versus you are doing the work for a financial industry, because industries differ and they significantly require different type of approaches, and also the concepts and details. Assume you are addressing a business-centered rather than technical audience. As such, you may want to include introductory summaries of key concepts focusing on data governance framework and that are strategically important and relevant to this client. You may include success metrics and any other tools or visualization to show the benefits of a particular strategy. Demonstrate to the client how you will minimize their data governance risks. The points are given. The first one is 10 points, second one is 50 points, next one is 20 points. And your plan will include critical components, expected timeline, and sequencing your rollout and implementation recommendations. Follow the posted best practices recommendations for creating effective video presentations. That's 10 points, and 5 points to make sure that your references are all following CMAS 17 author date references, and post the link to your video in the assignment link and list the names of the group and the roles in the project in the comment section. That's again 5 points. So those are the details about your data governance framework. Encryptions. Some definitions from D. Groot. The purpose of data encryption is to protect digital data confidentiality as it is stored on computer systems and transmitted over internet or other computer networks. The outdated data encryption standard called DES, data encryption standard, has been replaced by modern encryption algorithms that play a critical role in the security of IT systems and communications. Data encryption translates data into another form or code so that only people with access to the secret key, formerly called a decryption key or password, can read it. So encrypted data is commonly referred to as ciphertext, while unencrypted data is considered as plain text. Is called as plain text. Currently, encryption is one of the most popular and effective data security methods used by organizations. Two main types of data encryption exist: asymmetric encryption, also known as public key encryption, and symmetric encryption. So what is the difference between symmetric versus asymmetric, which is also called public-private key encryption method? So in the symmetric encryption method, the sender who has a plain text or data and the usual ASCII data that we all look at it and interpret it, goes through an encryption process through a key, some key, okay, which is as simple as a password, for example. And that converts that into a cybertext, which means it's encrypted, okay, and that is sent to the recipient, who can use the key which will be given to the recipient to unlock it. Okay, so there is one key that that key is used to encrypt and decrypt, okay, to get back to the plain text. So that is the symmetric encryption method. In the case of asymmetric encryption method, we have what is called a public-private key. So the recipient, okay, who is given a two-part key, and the recipient has the recipient's private key, and the other part, it's a two-part together, is considered as a key, okay, and the other part is the recipient's public key that he can share with others. So others will code the plain text, encrypt the plain text into encrypted ciphertext using the public key. But then the private key, which is secret with the recipient, unless you use that private key, it can never be decrypted. So it's a kind of two-part keys, right? Two-part keys. And so when the recipient receives the ciphertext, he uses the private key to unlock it and to make it into plain text that he can use it, okay, as a recipient. So that is what the asymmetric encryption method is, which is also called public-private key. So it's very important. So I just thought I will give you a small introduction on that. Encryption algorithms provide three things. Okay, one is it provides the authentication, which means the verification of the message's origin. The second one is integrity. It supports, it validates integrity. What does that mean? It means it is a proof that message contents have not changed while sending or during the transition. Okay, the encryption algorithm assures that. And then the final one is non-repudiation. The message sender cannot deny they sent to repudiate is they sent. To repudiate is to deny the truth or deny association with something. So the sender cannot repudiate that, no, I didn't do it. Okay, so that's the idea. So that's very important, right? Sender identifies that I'm the one who sent this message, document, data, and it has integrity, that it is not tampered on the transition or in the beginning, and the authentication is that the message origin is verified. So all these things are assured through the encryption method. In review, plain text or data is encrypted using an encryption key and encryption algorithm. The result is that it creates ciphertext which must be read with the correct encryption key. So the goal of the encryption is to protect sensitive data within an organization, example, to prevent employees from going someplace else with the data or corrupting the data from within the organization. And there are two methods of encryption. Symmetric encryption means same key encrypts and decrypts. The key has to be sent or given to the recipient of the ciphertext to unlock it into plain text. On the other hand, asymmetric key is that it's a public-private key, a pair, and the private key is kept by the user, by the recipient. Okay, everybody can be a recipient for some process. So the private key is kept by the recipient, and the public key is given to the encryptor. So you give the public key to the encryptor converts the plain text into a ciphertext using the public key, and then the recipient receives that encrypted ciphertext and uses the private key to unlock it. This process has been invented and validated, established well under the name called RSA encryption method. And that is the inventors' names are Rivest, Sharmir, and Adelman, and that's why it's called RSA algorithm, and that's what created the RSA algorithm for everybody's use. Very popular, very famous, and it's very hard to break into. The mathematics, they proved and applied it and implemented it in the current computational platforms. Apparently there was a version of it, the mathematics of it was available, but then because of it was too early to implement, because it requires a huge amount of compute power and also the latest computing technologies to implement it. So these people, RSA people, got the claim to fame for that invention, total invention. Just symmetric encryption is faster but requires sending the key to the recipient. Asymmetric keys are usually used to exchange the keys between companies. Okay. There is important, I want to bring out an important, idea that we need tools. We can't just go and encrypt to do all these things ourselves. So there are some important tools that are available. Hardware security keys and tokens are used commonly. Hardware security key or token means a physical device is used to add extra security to online documents and systems by requiring you to have the device with you to log in, a form of multi-factor authentication. In the earlier days, a lot more. And many large companies use security tokens, Amazon, Apple, Google, and so on. So the characteristics are, it's a small portable physical device that can be used with USB-C, NFC, or Bluetooth devices. NFC is another technology, near field communication for mobile phones used with apps such as Google Pay or Samsung Pay or Apple Pay. Very short range, is shorter than Bluetooth. That's why you have to tap the payment system actually with the equipment for NFC implementation. So these are all the images of how the hardwares are used. Mostly they are insertion as a USB or USB-C, or this is the Bluetooth NFC. Preventing data loss, how to break into the encryption system, brute force. People try to do this, trying random keys, works best with shorter keys, but then side channel attacks going after the implementation of the cipher works best if there are errors in the algorithm, and crypto analysis, finding a weakness in the cipher works best if there is a flaw in the cipher. Okay, RSA avoids all those things. Data encryption solutions, data loss prevention solutions, malware prevention methods, and ensuring devices are secure, ensuring applications are used correctly within and outside the organization, and always send an encrypted email. So this is a very quick review of the encryption methods and how do we prevent data loss due to any faults in the encryption process. Elements of a successful encryption strategy are the following, and that will mitigate risk and maximize ROI are the following. Collaboration is very, very important, bringing together key stakeholders. Data classification, information is divided into predefined groups that share a common risk. Okay, and key management, guard your keys. Key lifecycle management, you can't keep the same key for a long time, so there are, as the technology changes and more sophisticated encryption methods are coming in, you need to replace that with a new key. Heterogeneous key management, if you have too many keys in the organization for too many purposes, make sure that you centralize the operation. Key management is centralized. Find solutions that fit your organization. So access control, consequences, be aware of all these things, who is having the control for the keys, and how are they managed, how are they centralized, what are the consequences of not following through a set procedures that helps key management. And then SSL decryption methods. To manage HTTPS sites, you need SSL decryption and secure socket layer application methods. Okay, so that's high-end software technology. Okay, in terms of world map of encryption laws and policies, I would say there are kind of 1, 2, 3, 4 colors are here, right? Minimal restrictions are in US and Canada, for example. You can see that there is a country on this side here, and also a couple of countries in Europe. Widespread restrictions are for example China, Russia, and Iran, Pakistan, and India, for example. Okay, and no information available is a lot of countries in Europe, Greenland, for example, South America, some countries in South America, it's also Central America. We don't have much information about how strict they are. Okay, very interesting how it gives you a quick review of the worldwide implementation of encryption laws. Blockchain. So this is a very interesting new technology, new development. Blockchain encryption works in the following way. See how blockchain encryption works. So data on a blockchain are recorded openly and transparent. There is no secret there, okay? And it cannot be changed, okay? That's very important. It's called immutable. Data on a blockchain are immutable. The blockchain ledger, that is called ledger, okay? Blockchain ledger records every transaction ever on that blockchain, okay? It's transparent, it's open. It's verified, uploaded, and secured by anyone on that particular blockchain network, okay? So, anyone in a particular blockchain network, they can verify, upload, and secure the data, the ledger, or additional data can be posted. The Bitcoin blockchain is the largest, but many other new and upcoming blockchain technologies use technology that records every single transaction. There has never been a Bitcoin breach. Why is that? That's a very important question, okay? And okay, I will explain how blockchain works. Then you'll be able to understand why it is not breachable. Blockchain is a decentralized digital ledger. So ledger means transactions are recorded. It is decentralized, which means it's open to everybody and everybody can have a copy of it, and they do. Okay, and but the point is it securely stores records across a network of computers in a way that is transparent, immutable. It cannot be changed. Okay, you can add, but you cannot change it. Whatever the records that happen, and resistant to tampering. So all the history of transactions are combined into a block. Okay, and each block contains data, and blocks are linked in a chronological chain. That's why it's called blockchain. Blockchain is a type of shared database that differs from a typical database in the way it stores information. Blockchains store data in blocks linked together via cryptography. Okay, blockchains store data in blocks. Okay, in blocks linked together. Those blocks are linked together via cryptography. Okay, different types of information can be stored on a blockchain, but the most common use has been as a transaction ledger. Okay, who sends to whom, what amount of money, and so on. In Bitcoin's case, the blockchain is decentralized, and so no single person or group has control. Instead, all users collectively retain control. It's a very interesting concept, right? Decentralized blockchains are immutable, which means that the data entered is irreversible. For Bitcoin, transactions are permanently recorded and viewable by anyone. So, that is the kind of principles by which the blocks are coming together. Okay. Now let me explain a little bit more. A blockchain is basically a distributed database. Our database is called a ledger of transactions. Everyone in the network has a copy. That's a simple principle. What are blocks? Transactions are grouped into blocks. Each block contains a list of recent transactions, a timestamp, a reference to the previous block, a cryptographic puzzle solution. Proof of work in Bitcoin is done by a cryptographic puzzle solution. So the blocks means transaction grouped into blocks. That's what the blocks is. All transactions, okay, are grouped into blocks. Each block contains a list of transactions, recent transactions, timestamp of those transactions, a reference to the previous block, okay, in which that transaction has resulted into one of these current transactions in this block. Okay, and then a cryptographic puzzle solution. All these things are part of each block, and then they are chained together chronologically. Now, there is hash that come into play. Hash is a way of it's basically a mapping. It's similar to a key, but it's a mapping of characters to a document. In this case, a block. So each block's unique hash depends on its content and the previous block's hash. So each block's unique hash, that it's a kind of key, okay? And the hash depends on its content and its previous and the previous block's hash, okay? Previous block's hash. Remember that. If someone tries to change even a single transaction in the older block, the hash changes because the hash has a connection to the contents, right? The hash changes, breaking the chain. So, we know that it's broken. The consensus. What does consensus mean here? The network, miners and nodes, agrees on the valid chain using consensus algorithm. In Bitcoin, it's called proof of work. So that's what is also connected to the cryptographic puzzle solution. So network of miners and nodes agree on the validity of the chain using consensus algorithm. The longest valid chain with the most computational work is accepted as the truth. The longest valid chain with the most computational work is accepted as the truth. Because thousands of nodes maintain the ledger, no single entity controls it. Okay, so that is what is called the decentralization. I just gave you a very important highlights of the blockchain, how they work. As transactions are how grouped into blocks, and blocks are connected, by the blocks are chained together by the chronological order, and they are chained together through the hash algorithms, and the hash algorithm depends on current block's content and the previous block's hash. Okay, and so and people are given an opportunity to prove that the what is the to find out what is the longest valid chain with the most computational work, and that proves the validity of those unbroken the chains, and hence all the transactions are the integrity of all transactions are maintained. Okay, because and it is decentralized because thousands of nodes maintain the ledgers. Okay, now it's in the picture form is what is mentioned here. In this slide, I'm showing you how the adoption rates are around the world. For example, India is one of them, and as well as Korea here. India seems to be one of the highest adopter of cryptocurrency, while almost 25% adoption happens in USA and Canada, and almost nil adoption in, for example, Saudi Arabia, for example, or Mongolia. Okay, so that's how you interpret it, and that's worldwide adoption of cryptocurrency. And in terms of regulations, you can see that India, Russia, and Europe, as well as USA, Australia, and so on, they have regulated the crypto usage, but China totally bans it. For example, absolute ban. Okay, so there is an implicit ban, for example, in Saudi Arabia, for example. So that's how you interpret here with this nice global map. Regarding China, in fact, it comes out to be a case study in your case. Don't assume China will ease crypto restrictions anytime soon. The timescale reads as follows. By mid-2023, China was very restrictive with cryptocurrency. And then by mid-2023, towards the end of 2023, world financial markets anticipated that China would loosen its policy and allow cryptocurrency. But then, January 2024, China cracked down again on not to use cryptocurrency. So that's the stand. That's what happened in the history about China's adoption, and I don't think it is going to easily. China is going to come back and say that they are going to accept cryptocurrency soon and easily. In terms of the Bitcoin impact on the environment, this is a video published in 2022. It's a group called Digital Wildcatters in Texas. They go after heavy energy, farming, and as well as using it. And the energy sources feed directly to crypto mining in Texas by the wildcatters. Crypto mining is energy intensive, responsible for 2% of Texas energy consumption, and the crypto evangelism, also supported by Ted Cruz, the senator from Texas, argues that poverty is connected to pollution, and wildcatters argue that energy use is not an environmental problem, that the energy Bitcoin consumers is a net positive, that it's no harm to the planet. They argue that the Bitcoin industry will spur new technology that will result in better solutions, more than what is currently available. That Bitcoin is a distributed economy. Crypto mining also uses old values that would otherwise be flaring. Others argue that Bitcoin, crypto, cybercurrency mining consumers use too much energy. There is too much methane leached into the environment, and also externalities to be managed due to the energy usage and energy harvesting. Or should the wells be capped and not used at all? These are the questions one has to think about it. Currently, Texas is kind of still Wild West in farming energy and using it, and it has those resources also. Huge sunbelt area and oil, methane, locked under its land. There are alternative ways to mine cryptocurrency without using so much energy. Is this an ethical issue on the other hand? Okay. Should it be banned like China did, or can capitalism sort this out? Cryptocurrency is banned in China and 8 other countries. Watch out for greenwashing. Okay, terminology used for transforming green energy for cryptocurrency. Data centers in Washington State, for example, are there is already something like around 9 data centers are available huge data centers are being built in Washington State, and data centers are coming around all over the country. Texas is also another place. People are building data centers. And now recently, today I heard a news that Applied Digital is building a data center in Nevada, for example. And so all over data centers are going to come because we need data centers to run the internet, especially AI, LLMs, okay? And we need energy for that, we need water for that. So I would encourage you to read this, the cryptocurrency mining statistics, 2024 profitability, environmental impact, and regional leaders. Also Forbes article, how tech companies are powering their operations with nuclear and renewables. So again, we don't have enough energy to run the internet as well as the AI development work, especially the large language models, OpenAI, XAI, and so on. So Google AI, Gemini, and so on. So people have started using the nuclear option in terms of generating energy, and also more and more of renewables are also brought into the mix. So if you are watching the stock market, you can see that the stocks for nuclear energy companies are going up recently, and also even for renewables. Okay. Data governance in the news, it's published in 8/14/2025, August 14, 2025. License plate readers raise privacy concerns across the country. Chicago Sun-Times, the widespread acceptance of automated license plate readers as a crime-fighting tool only magnifies routine surveillance of a sort that would have troubled the Fourth Amendment's framers. And 8/13, one day previous to that is, there was an article published. This is about New York Attorney General sues Zell's parent company after Trump administration drops similar case. New York Attorney General Letitia James' case against early warning services alleged that Zell, which allows users to send and receive near instant money transfers, failed to include adequate verification processes. Scammers were able to access people's accounts or trick users into sending money to bogus accounts that post as official businesses. So there is it's a fight always, the regulation, deregulation, and Zelle is a classic case. Zelle makes my life also easy to send money, but then these are all possible problems that they have to take care and address. So that concludes my presentation for this week. So please note this key informations bits, and I will post about the submission dates for the what needs to be submitted when, as part of the posting of this document in the announcement. Thank you.